Hi everyone, this is my final exam portfolio from MTHED 323. I was not able to add an audio to my presentation with it working correctly, so I am just going to link a video instead. Here's my table of contents. I included the topics at hand that you can find on the slides, as well as the specific week assignment that I posted for every topic. As we move into math history, it's so important that you teach math history within your classroom because it provides students with more motivation as you're explaining the origin of where their learning is coming from. So a lot of students feel as though, like, why do they have to learn this? Why are they going to use this in their future? Teaching about the math history allows students to build that understanding of um, this math came from a source and it now has progressed to what they're learning. And that kind of moves into math is not a book of absolute truths because as people are continuing to explore and hypothesize and prove things to either be true or not true, math is constantly changing, and so are a lot of other subjects such as math. And um, so as students are investigating their problems, they can understand that history will continue to change and that will build that motivation. And how would you incorporate this within your own lesson plans? You can include some biographies of some mathematicians, as well include that math history within your word problems. And then I included a link to a math history essay that I had wrote. As we move into the CRA instructional approach, this is a three-tiered instructional strategy that focuses on different developmental levels. So at the first level, this is going to be hands-on learning with like manipulatives. And then as you move into a little bit higher of a level, you're at the representational, and this will be visual models that are 2D. And then the last phase of the instructional strategy is an abstract learning, and that's when students have developed a conceptual understanding of the other concepts being taught. And some of the examples I included were like concrete, could be algebra tiles, any sort of manipulatives, and then representational, I included area models as these are 2D, and then abstract, these would be like the equations, and when students have that deep understanding, now they can work on the procedural understanding. And then I included a document of me including the representational approach to solve one problem. And then the CRA instructional approach is specifically designed to meet the different developmental levels of your students. If you have students who are below expectations for learning, you can include those manipulatives in the lesson, as well as those students that are exceeding expectations, then you can have them already solving those abstract conceptual understanding problems. And then as we move into fractions, it's important that when you're teaching how to add fractions that you focus on that you need to change the denominator. So to scaffold this, you would explain to students that the size of each fraction within the equation, they are not the same size pieces. So they cannot be added together until they are the same size. So you can do this through visual models such as a pie chart, a rectangular visual where you split the rectangle into pieces, or the manipulatives of like fraction strips. Students can actually construct their own understanding with those manipulatives. And then how would you address some of the misconceptions that students have? So a lot of students feel as though that they need to add the top two numbers and then the bottom two numbers, and you can address this through those real world word problems such as relating it to pizza sizes and those visual models again. And then I included a document of how students had made some mistakes within their problem solving, and how I would scaffold this learning through different visual models. How I would teach integers. Integers are so important that students understand before they move into other concepts. So it's important that you spend effective and adequate time making sure that students really understand this. And you can do this through visual models such as number lines. So you would scaffold this learning by having students focus on if your number is going to either decrease, you would look to the left, or if it's going to be positive and increase, then you are going to look to the right. Um, and you can even do this by including some real world word problems by having money or temperature so students can compare this to the understanding that they already have through their own lives. And then how would you address this if students are working on a very difficult integer problem? You can have them represent the problem using different markers or manipulatives such as like a red block and a blue block. So like the two color blocks would cancel each other out or take them away, and students can construct this own understanding. And then I included a document of um, how I would scaffold learning, again by um, including some different strategies about how to teach integers. And then algebra. When you teach algebra, it's important that students know what a variable even is, because they might see that letter within an equation or um, a word problem, but they aren't really understanding what that variable actually means to the problem. So it's important that you first start out by teaching that variable represents something else, and you can do this through hands-on activities and number lines. um, and then it's so beneficial to also include word problems through algebra. So you could have Bob makes or has $5 more than Stacy, and Stacy has $25. So how many dollars does Bob have? So um, students can relate this to the money situation, as they already have some understanding of money, but they're realizing that we don't know what Bob has, and we are trying to find that out, and that's that variable component. And then using manipulatives and representational models, students can use like algebra tiles to build that connection even further. And I included a document that I completed that describes some students' work that um, had some misunderstandings about equality, and how I would use different hands-on activities and number lines to address these concerns that they have. And geometry. So when you're teaching geometry, there's so many different tools to build that conceptual understanding. Um, And it's important that you use these because students need to construct their own understanding. When they're manipulating these objects, they're building those connections within their own minds, and then they can move forward into that representational and then even abstract. And this is when they can start classifying shapes and different properties of these shapes. So I included a couple different examples, so 2D and 3D objects of shapes, protractors. You can even include like different books of or literature, um, like building an initial understanding, or like um, bringing the concept to the classroom through different books. Geoboards are such a great tool for students to build their own shapes, and then those real world examples, you could have students pick out shapes with it that they see within the classroom. When you teach geometry, you need to understand the Van Heel levels of geometric thinking, because these are the different levels that students have of um, their development. So students at the very last or lowest level, they do not have much of the classification understanding. They can recognize shapes, but there is not much properties being recognized. But as you move forward and students are gaining more understanding on different shapes, then they start to classify and relate these properties. And that makes your planning for your lessons so much more intentional and effective, as you need to plan lessons specifically tailored to their your students' Van Heel levels. And that will also allow you to understand where your students still yet need to grow. Then I included a document of me completing a triangle classification. And then lastly, technology. Technology is a great tool to include within your classroom, but it's important that it um, is just an additional tool and does not take away from your actual instructional activities. So, some of the technology criteria that I thought was most important was it needs to be user friendly as well as relevant to the learning. It needs to meet the learning objective. If the technology is not meeting the learning objective, there's no point in including it within the lesson. And then some technology that I'm familiar with is Khan Academy, Desmos, and iReady. And like I stated before, technology is supposed to enrich the learning experience when students um, are using it. So one lesson that I could include would be teaching students about algebra. Students could explore algebra tiles digitally so that they have those manipulative algebra tiles hands on in the classroom. And now they're applying it to the technology version and seeing how they're the same and different and how they can alter these. And then included a very brief sample lesson plan activity that I found on Desmos.